In this section, I'm going to give a very high-level overview of what Jenkins is, how we use it, and what we should be using it to do. At its core, Jenkins is a Java-based application. When it runs inside of a Java application environment. It's also agent-based. From an architectural perspective, when Jenkins runs, you have the ability to then have it delegate to individual agents, they could be machines or VMs, for actually running individual jobs. Jenkins is otherwise a plugin-based architecture, meaning that Jenkins has a core set of capabilities, for example, being able to compile Java, but you can find additional capability from third parties or the Jenkins company itself for doing things from everything from Android development to iOS-based development. At the end of the day, Jenkins is what's known as a continuous integration platform. It's used for, or was at least initially used for, performing continuous integration activities. Its use cases have extended beyond continuous integration though. CI starts with detecting changes in source control, triggering some sort of job or pipeline for automatically running tests, running verification, and then notifying parties of what happened. It's moved beyond that to where now Jenkins is also used for continuous delivery activities, specifically deployment automation. Instead of having humans have to transfer files and run commands at the command line, Jenkins can be used as an orchestration hub for executing these activities on the behalf of what would normally be done by human beings. There's additionally plugins to do everything from Kubernetes-style delivery to connecting with a Tomcat server and launching a Java application. At the end of the day, if a solution doesn't exist, you're capable of building it on your own. And finally, there is an ad hoc sort of use case that comes with Jenkins. In a lot of places, you'll find that you need to do something, gather information, but you don't have an application runtime environment that can do that. Jenkins can be used as a sort of stopgap to, for example, create a job or a pipeline to run, do something, take the results, send it somewhere, and then spin back down again. This is known as a more ad hoc use case that Jenkins is used for. The Jenkins architecture starts with what is known as the Jenkins master, or now called controller. This is the instance in which all the developers interact with. It's divided up into jobs, also pipelines, but these represent individual runtimes that are executed on agents for doing something, whether building a Java application or running Selenium-based web automation. Users refers to the people that are able to operate Jenkins. This can be integrated via SSO with most other people's systems and companies' user management systems. The plugins refers to the things that come with Jenkins itself, but that you can also download, dealing with, for example, a checkmarks integration. Credential management is also built into the platform as a way to store secrets in a way in which people can't get direct access to them, but then you can use them in jobs that require credentials. In terms of the agent-based architecture, the idea is that the Jenkins controller can delegate the individual job runtime to, for example, a physical slave sitting out there either on premise or somewhere else. Additionally, there's the option of using dynamic containers. There are cases where Jenkins can integrate with Kubernetes, for example, which will spin up a container, run the individual pipeline, and then when it's done, spin the pipeline back down again. Jenkins has several core features, but we'll start with what I believe is the most important, pipelines as code. This is the idea that I can write code to be the pipeline. Instead of having to go in and configure some web user interface, I can actually have the pipeline itself sit inside my own code base. That's used to then figure out how to do everything from building, but also I can handle delivery through a pipeline as well. Jenkins additionally has the ability to have those pipelines be shared libraries, meaning that if you have some common pipeline for doing stuff, you can actually take that, centralize it at a location, and then use that instead of having to copy and paste all that code. I will caveat this though and state my personal preference, which is that you want to be very, very careful about baking logic into your pipelines. Anytime you bake logic into one of your pipelines, you're tightly coupling it with the underlying pipeline technology. Also consider that you can only test it within inside the actual Jenkins runtime environment. That is why my preference is when it comes to logic, you want to keep that inside the build technology itself instead of relying on the pipeline technologies. My opinion is thus that pipelines should be used as high-level orchestrators. There's also a good user interface and good user experience for managing how pipelines work. There's a GUI you can go to, you can see jobs run, you can debug them, you can manually launch them, you can do all sorts of things through a graphical user interface, including looking at detailed reports such as code coverage metrics. There is also, as mentioned with the plugin architecture, a number of integrations. These integrations are additional plugins, HPI files, you can actually add to your Jenkins environment in order to do additional functionality that wasn't baked in. I will throw another caveat here saying that consider that every integration you add has to be maintained. Jenkins continues to evolve over time, as does such its integrations. So you want to be very careful about including an integration because that integration is going to have to then live with that Jenkins instance.